Hi, welcome to Dive Deeper, everyone. My name is Sam. I'm the Animal Exhibits Manager here at WonderLab Museum in Bloomington, Indiana. And today we're going to talk about bioluminescence and biofluorescence. So let's go ahead and get started. So these are two really big words for glowing, for animals that can glow or make light. Do any of you know any animals that can glow? Mary said eels. That's true, some eels glow. James says glowworms. Amber says jellyfish. Haynes says lightning bugs. Yes, these are all animals that glow. Now, why would an animal need to glow? What would that do for an animal? Why is that helpful?
To scare away animals.
Yeah, maybe that might be a good one. That might be a reason an animal would glow. Yeah. Mary says to see where you're going, kind of like a flashlight. Yeah, maybe. Yeah. Any other ideas? Why do animals glow? All right, I think you guys came up with some good ones. That's absolutely true. Other reasons an animal might glow is to attract others of its own species, to communicate. It's kind of like for us, I'm communicating to you right now by talking. But some animals, they don't talk. They don't have vocal cords like we do. So how are they gonna communicate with each other? How are they gonna talk to each other? Sometimes they glow, like our fireflies, like we talked about. In summertime, you can sometimes see them blinking, like lights on, off, on, off. And each of those blinks means something. They're communicating information. They might want to look for prey, like so they can lure in prey, kind of like when you go fishing. They can use those to attract in food to eat them. There are lots of reasons that an animal might glow. Now,
in the chat, Sam, we have to attract a mate and to attract other animals that it might want to eat, like an anglerfish.
Oh, that's a really interesting animal, and one of the, in my opinion, one of the most interesting fish in the ocean. They do a lot of really cool things, and it's funny you should mention an anglerfish because I have photos of them. For those of you who don't know what an anglerfish looks like, look at that fish. Look at that mug. He's got this big old upturned mouth, but this little lure right there, that little fish hook almost right at the top. They use that to lure in prey. And we're going to talk a little bit more about that soon. So these are really interesting points, and they're all true. So how does an animal glow? We can't glow. Humans are not glow in the dark unless we're wearing highlighter clothes. So how can an animal do it? Well, the animals we've talked about do it in two different ways. And the first way we're going to talk about today is bioluminescence. Bioluminescence. Let's clap that one out together. Bioluminescence. Bioluminescence. It's a big word. And what it means is that the animal inside its body creates its own light. So using chemistry, mixing of chemicals inside the body that they are producing, the animal is able to make its own light, which is really, really cool. And have we all seen glow sticks before? So these glow sticks work in a similar way. They're full of a special chemical called luciferin. 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 And it's a chemical that when mixed with oxygen, like we breathe, it makes light. So we've all, I'm sure, cracked our glow sticks before. And when you're doing that, when you're cracking a glow stick, what you're doing is you're mixing chemicals. You yourself are creating a chemical reaction. And animals in the ocean and on land do this inside their bodies. So they have special cells that are creating this luciferin, and they're mixing that luciferin with oxygen. So for an anglerfish, like you mentioned earlier, down in the deep, deep, deep ocean, there's no light down there. The sunlight that we see can't make it all the way to the bottom of the ocean, can it? That's really, really deep. So how can an animal see when it's down there? Bioluminescence. They're creating their own light, like that anglerfish we talked about earlier. So this property is super important for animals that never see the light, like those guys who live really deep in the ocean. They never see sunlight, so it's important for them to be able to lure in their prey with their own little light, or to be able to see and talk to each other that way in the dark. Now there's another really cool animal that does this, and it's called plankton. Have we all heard of plankton? They're those really itty bitty, tiny, tiny microscopic. Well, not all of them are microscopic, but they're very itty bitty, and they float in the water. And they also are able to do this chemical reaction. And I have a really fun video, I think it's really fun, that I'm gonna show you of some plankton from California. So what you're about to see in this video was taken in the dead of night. There is no sunlight. And what we're gonna be watching are the waves crashing into the shoreline. So I'm really excited to show you all this, and I can't wait to see what you think about it. So everything you're seeing, all that light isn't coming from the sun or anything we can see. What's doing it are these itty bitty, tiny, tiny animals. The plankton that live in the water are creating this chemical reaction inside their bodies all the time. You could see someone splashing their hand through the water. All of that is plankton, and they are creating their very own light. So I'm going to take my video down now. What did you guys see? What did you guys think of the plankton?
Oh yeah, it would be cool to see in person the bioluminescence at the ocean. Yeah, I agree. I see that in the chat. Mary says it's very neat. Yeah.
What's happening are all of the little plankton in the water are getting disturbed by the movement. And because of that, they're sending up a defense flare. They're making this chemical reaction, mixing the luciferin and the oxygen, and they're creating their own light. And this is happening every night in the ocean, all the time. So there's a second way animals can use light. So we're gonna talk about what light even is before we talk about the and light, you see it all the time. You're seeing light right now. The only reason you can see me on your screen is because light is reflecting off my face and into your eyeballs. So what's happening is we have all these squiggles. You see these squiggly lines. Those squiggles are called wavelengths. And every color of light in the rainbow has a different wavelength. So reds are really big wavelengths, and blues have really itty bitty wavelengths. So, and each of these wavelengths create a certain amount of energy. So do you guys think that big wavelengths or small wavelengths have the most energy? Which do you guys think have more energy? Big red light or small blue light?
We've got some guesses. Red light, big red light from James and Amber. Small blue.
I see a couple people have said the small blue light. So we have two different answers. Well, I have a small demonstration that might help you out. So I've got a spring. Can everyone see my spring? So when it's setting here, the space in between each of the metal parts, the coils, the space in between those coils are pretty big right now. And they're setting here and they have a certain amount of energy. And they're just sitting here, not going anywhere. But if I were to squish them like this and then let go, it went flying. So I've got this, it's setting here, but if I squish it, it goes flying. So which one has more energy, small or big? It's gonna be the small one. Small blue light has more energy than the big red ones because all of that energy is tightened up in an itty bitty space, itty bitty living space, and then it'll go flying. So light, when it's hitting an animal, has the same property. The smaller the wavelength, the bluer the light, the more energy it's got. So now that we know that, we're gonna talk about another way an animal can glow. But this way, it's not happening inside the body like luminescence. There's a chemical reaction in the body. What's happening is the body is using the light created by the sun. And that is called biofluorescence. Biofluorescence. So, biofluorescence. Biofluorescence. And this is when an animal, it's got all these special proteins in the skin. So like some of the animals in the aquarium we're about to look at, they have receptors on them and they've got these proteins, all that are made of atoms, these little itty bitty tiny particles. So I'm gonna show you what happens when the light, the blue light, hits that protein. So say this is my protein and this is my electrons. What happens is they start really close together and they're just kind of looking normal, kind of like the little corals I've got setting here. They've got proteins in their soft bits. And right now with the full white light that's coming on them, you don't see much glowing at all. And that's because the electrons are really close to that protein. But when blue light hits it, that strong blue light, the electrons get real excited and they start floating out here. And then what happens is when that energy's gone, they drop back to it and they release energy in the form of other light. So it may look green or it may look red. If you remember earlier, they have less energy. So when that electron drops back down, it'll emit its own light. Are you guys ready to see that in the aquarium? See that in live action? Keep an eye out in the aquarium and tell me what looks different after I change the lights. So take a good look at it right now. And now, what looks different in the tank? Do you guys see anything that looks different? Yeah, some of the rocks and all of these beautiful bright greens that you see, that's coral. That's an animal in there. So what the animal is doing, what that coral is doing, is what happens is that blue light hits it, and then those electrons jump up, and then they fall back down. And what you're seeing is the electron falling. That falling creates the pretty colors, the glowing that we see. So if we look back, if we remember our corals right here, you can see what they look like regularly. And let's see if they too change colors when I bring the light. Is it glowing? Yeah, it kind of glows there. It's hard because of the light setup, but I have a much more drastic
Hey, Sam, in the chat, Karen said, I see different things show up that I didn't notice before when you changed the lights.
Absolutely. And that's a very interesting point and a very vivid observation. So that's an interesting point. So the animals, when there's not the blue light, can hide a lot better. So what happens is when light hits the water column, very much like the prism I showed earlier here, light hits the water column and we get a rainbow. And so what's happening is the white light that we're seeing from above, from the sun, hits the water, and then it splits into all those different wavelengths that we talked about. And then the blue light is the only one that makes it all the way through the water. So the red light is less energy and it kind of gets lost as it goes back down. And then the oranges get lost, and then the yellows, and then the greens, and all you're left with is this blue light. And this blue light is broken away at only certain parts of the day. It looks this way. So those animals that you see, that you didn't see before, were able to hide really, really well for the rest of the day when they need to be hiding. But when the right time of day comes, and they need to do things like hunt or mate and live their lives, that's when you can see them. And because that's important so that the other members of their species can see them as well. But they only need to be seen during the times that they're active, so they can hide really well at other times of the day. That's why you only see some of them, and you may not have noticed things before. That's a really interesting observation. And I'm sure if you come to WonderLab, when we open again and you sit throughout the day, you'll see all kinds of new things throughout the day. So I've got one more thing to show you guys, one more glow experiment. And it's something you can do at home. If you've got a dark light like this, or those holiday lights that are kind of purple, those will work fine with this as well. So I've got just a cup of water. It looks normal, right? Not glowing, nothing like that. Well, I took another cup of light, or another cup of water, and I just dropped a highlighter in it. I took the cap off, and I just dropped it in there, and I let it set for a while I waited for you all to join me. And so this is what it looks like without any light on it. Kind of clear, a little yellow, not too much different. But if I take a light to it, it's glowing like a jellyfish or an eel or an anglerfish. So you can see that humans have taken things we've learned from animals like bioluminescence and fluorescence. We've taken things we've learned from animals and applied it to materials we create, like highlighters. So humans use this information that we learned from animals in a lot of different ways for our own use here on land. So, does anybody have any questions about anything we talked about? We talked about a lot.
Let's see, we've got a comment in the chat. Diane says that they had little spots glowing under and around a wood pile on their land. Was that sort of like what's lighting up in the coral reef tank when you change the lights?
Yeah, well, that's a great question, and one I'm gonna have to think about, because I have to think about what could potentially be on your wood. So that could potentially be a bacteria of some kind. It's the same process of the fluorescence and the luminescence. I don't know what species you saw, so I can't tell you which for sure. But what you're seeing is the same process, just a different animal doing it. So you're seeing in the coral, their protein is in the skin. So coral, while they're hard, they still have an epidermis, a little kind of like ours, a soft tissue. And there's proteins embedded in that. Now in a bacteria, it's a little different because they don't have skin, but they're still able, using those tiny little organelles that are inside their bodies, they're able to do the same chemical reaction or have a similar protein that do the fluorescence. So while you're seeing the same process, but the different animal doing it. Well, I had a great time with all of you. Please join us here next time for Dive Deeper here in WonderLab, or join us for one of our other programs.